Today in this video we will discuss malware static analysis, but before that, we must know what malware actually is. Malware. Malware, short for malicious software, is any type of software intentionally designed to harm or exploit computer systems, networks, or devices. Why do people design malware? The intent of malware is typically to gain unauthorized access to a computer system, steal data, disrupt normal system operations, or cause damage to the system or its users. Malware can be analyzed by various methods, but in this video we will discuss static analysis. Static analysis is a method of analyzing software code without actually running or executing the code. Why we use static analysis? Static analysis can be used to identify code defects, such as syntax errors, memory leaks, and uninitialized variables, as well as to detect security vulnerabilities, such as buffer overflows, injection attacks, and race conditions. Techniques used in malware static analysis. Malware static analysis use following techniques to identify malware. Code disassembly, breaking down the code into its basic components and instructions. Function identification, identifying the functions within the code to determine the purpose and behavior of the malware. Signature matching, comparing the code of the malware to known signatures and patterns of other malware programs to identify the type of malware and its origins. Behavior analysis, examining the code to determine how the malware behaves, such as whether it contacts a command and control server, downloads additional malware, or steals data. Risk assessment, evaluating the level of risk posed by the malware and making recommendations for how to mitigate the risk. Control flow analysis, examining the flow of control within the code to identify potential vulnerabilities in the system. Data flow analysis, examining how data is used and modified within the code to gain additional insights into the behavior of the malware. Malware static analysis has following benefits. Ability to identify new or modified malware that may not be detected by signature-based detection methods. Provides valuable insights into the behavior and purpose of malware, which can be used to develop effective countermeasures to mitigate the risk posed by the malware. Prevents further damage to the system by examining the code statically instead of running it. Limitations of malware static analysis. Malware authors often use techniques to obfuscate or hide their code, which can make static analysis more difficult. Malware may have additional components that are not visible through static analysis alone, which can make it more difficult to fully understand the malware's behavior and purpose. Preventing malware. Malware can be prevented by following steps. Keeping software and systems up to date. Using antivirus and anti-malware software. Avoiding suspicious websites and downloads. Using strong passwords and multi-factor authentication. Backing up important data regularly.